As we start lesson 2 of chapter 2, put a little drawing up here. This is sort of a scale or a teeterboard, and this is the fulcrum, and this is the same as this, and it's equidistant from the fulcrum. And as you can see, it's balanced. So this is going to be sort of a visual model of what an equation that we'll start looking at is like. Now, if I add something to this side, then this is not going to be equal or balanced anymore. But if I add the same thing to the other side, then it's not the same as it was originally, but it's still balanced. And in the same way, if I take away something from this side, it's not going to be balanced anymore. But if I take away the same amount from the other side, then it's balanced. And if I take away a little bit more from this side and a little bit more from the other side, it's not the same as what it was originally, but it still balances. But now over here, what's left on this side is an x. And what's left on this side is a 3. So by doing things to both sides, using algebra, arithmetic, we end up with just an x on this side, and then a value on this side. We have, in a sense, solved this equation. So keeping this in mind, let's take a look at some examples. And what I'm suggesting is take a moment on the left, write this out, and then I will model how to solve an equation. And this is what you will do in your homework log as you progress, and then eventually on your blue sheet when you take a test. And you may recall from chapter 1's blue sheet, and I'm assuming I would have been able to give partial credit for work. Okay, so again, we want to isolate the y all by itself here. So how do we get rid of a negative 6? Well, we said in fact, let me not put the equal sign there yet. We're going to add 6 here. That's the additive inverse of 6. And we add 6 here. So now, when we do this addition, we end up with y. Then we have our equal sign. This is going to be a 0, and this is 24. So this will be probably the easiest of the equations that you will do. And that adding something to one side and the same to the other side, it changed what we originally had, but it's still equal. But now we have a single letter equals a value. Okay, take a moment to copy this down. Fortunately, I have it written out here for me. Now notice t is already isolated here, as was the y. So we just need to get rid of the negative 5. What's the additive inverse? A positive 5. Add it to this side, add it to this side. So we then get t equals a negative 13. Now you might say, is it okay to have the t on this side? Yes. All right, some of these are very easy. Take a moment. We want to isolate the y. So we're going to subtract 8.1, subtract 8.1. We then get y equals, this is going to be 8, 5.8. Now there's another way to do this one, where we just subtract this from both sides, but we're still going to need to deal with fractions. So a technique that we will be using later, and I'll show it to you now, is how do I get rid of all our fractions, which is a good technique. And the technique is multiply every term by the least common denominator. And between a 3 and a 4, the least common denominator is 12. So this is one term, this is one term, this is one term. I'm going to multiply every term by 12. So here it's 12a. Here the 3's cancel with the 12, and I get a 4. And 4 times 2 is 8. Now notice the 4 will go into there once, 4 goes into 12 3 times, but it's a negative 3 times 3 is a negative 9. Now we want to get rid of our 8, so we'll subtract 8 here and subtract 8 there. Now it's critical you watch your signs. So this will be 12a equals a negative 17. Now something we're going to be doing down here and a little later on too, we want to get the a by itself. So how do we do that? We just divide by the numerical coefficient of the variable, both sides. So we then get a equals a negative 17/12. Now if you did it the other way, subtract this from both sides, you get the same answer. So there's different ways to do it, but this is one we'll be featuring. Now we're looking for technique. Here the x is not by itself, but it's isolated on this side. How do I get just a 1x? Well, often it's just to divide by the numerical coefficient. And if we do one side, we do the other. So these cancel out, and we get x equals a negative 9. Now, you'll notice I'm trying to keep the equal signs lined up, and I'm doing this in a sequential way. Now here, when we end up with something like this, what tool do we have in our toolbox to get x by itself? We want a 1x here. Well, from the previous chapter, we know if we multiply something by its reciprocal, we do both sides, then this all cancels out, and this just becomes a 1x here. And we can do some cross-canceling. And that's our answer. Now, again, we want this to be a 1x. So if we multiply this term by 3, and this side by 3, here the 3's cancel out, and we get x equals a negative 24. Now here we have a negative x. We always want to have a positive x value. So if we divide this side by a negative 1, and this side by a negative 1, this then becomes a positive x, and this becomes a negative 15. Now a rule in general is when you have a negative x equals something, a 15 in this case, all you have to do is change the signs. This will become a positive, and this side becomes a negative. And what are you doing in the background? You're dividing each side by a negative 1 that just reverses the signs. Okay, now in section 3, we get to some that are a little more complicated. So let's raise it up, and we'll give you a moment to copy these on the other side. Now, what I'll do is model these for you of what you should do. So first, we're going to distribute 8y plus 16 equals 4y minus 12. Now, notice we have variables on both sides now. We want to make them such that there's variables only on one side and numbers on one side. And we want to try to keep our variables positive. So I'm going to subtract 4y here, subtract 4y there. Now be careful when you're working with signs. This is a negative 4, a negative 4. Sometimes students will put a negative here, but they don't put the negative there, and of course they get the wrong answer. So this now is going to become a 4y, and this is going to be a this is 0. But I'm also going to, at this time, to save room a little bit, I want to get this 16 on the other side. So I'm going to go minus 16 minus 16. So again, these cancel out now, and these will cancel out. And you could put it in 2 steps, or you could do it like this, and this becomes a negative 28. So this is sort of the middle step where you have a variable on one side and then numbers on the other. Now you just want one of the variable. So here I'm going to divide by the numerical coefficient 4, and here by the numerical coefficient 4. So I then get y equals a negative 7. Now in letter B, we see there's like terms here. So our next step would be 10x equals 5x as we combine our like terms plus 20. Now we want all the x's on one side, and we're going to try to keep the x's positive. So I'm going to subtract here the additive inverse. So this becomes 5x equals 20. And you want to really follow what's going on. We're combining like terms. We're scanning it then and saying, I want to keep it positive. So if I subtract 5x from here, this will become a 0. But I must do it from this side. And now to get the x by itself, and this is how we usually do it, we divide by the numerical coefficient, and we get x equals 4. Try to keep your equal signs and your steps logical. Now, some authors will put the work horizontally. I think the idea of doing it vertically and this idea of like term columns is a helpful thing. To speed this up just a little, we're going to combine like terms here, and we get a negative 2z plus 5. This doesn't change. To keep our z's positive, we're going to add 3z there. That makes this 0. 3z there leaves us just with a z. We're now going to subtract 5 from this side and subtract 5 from this side. So we've gotten z by itself, and here this was a 0, this will be 5. So step by step. Now in this one, again, we're going to combine like terms. This will give us just an x on this side, plus 4. When we combine this, we get a negative 13. And now we're going to subtract 4 from both sides. We get x equals a negative 17. You'll be having lots of practice as you do your work, but there are some that I want to specifically review with you, and this next one's a good one where there's lots of fractions. So what did we say earlier? A technique when there are fractions. First, let's see how many terms there are. Well, this is one term. This is one term. One term. One term. So there are 4 terms here. And the rule is multiply each term by the lowest common denominator. Well, when we have a 6, a 3, and a 2, our lowest common denominator here is 6. So we're going to multiply each term by 6. And this is one I particularly want you to copy, so we'll give you a moment. Now, what we're going to do is get rid of all our fractions now as we multiply. Here the 6's cancel out, and we're left with a negative 1x. Here the 3's cancel out, That becomes a 2. So negative 1 times 2 is a negative 2. Here the 6's cancel out, and we're left with 5x. That cancels out. This goes 3 times. So we have a plus 3. So we've gone from a rather complicated fractional equation into something rather easy. Now we want to get all our variables on one side, and we're going to try to keep them positive. So we're going to add a 1x here and a 1x there. That makes this a 6x. This becomes a 0. Now we want to get rid of this by subtracting 3. Subtracting 3. This becomes a negative 5. And again, the steps, getting rid of fractions, getting all of our variables to one side, numbers to the other, and now we're just going to divide by the numerical coefficient. We get x equals a negative 5, 6. Now, in letter F, there are decimals. Well, those are considered fractions. So the key to get rid of fractions or decimals is after you scan it, there's only like one decimal place. So if we multiply each term, 1 term, 2, 3, 4, 5, 6, 7, and a way to do that, put a bracket here. We're going to multiply each term by 10. That will give us a negative 149, a positive 48. We had to add a 0 to move the decimal place over. This became a negative 27, a positive 28, 51, 70a, 15. Now we collect like terms. So now we have 60a in this and 70a. Want to keep our a's positive. So we're going to subtract 60a here, 60a there. So this is going to become 10a. And we're going to bring this to this other side. So we're going to subtract 66, subtract 66, and we end up then with 10a equals a negative 242. Divide both sides by 10, and we get a equals this. Now, that's different from the answer below, so I believe the textbook had an error here. All right, let's go on to the last part. And later in the chapter, we do lots of word problems where we have to convert English into algebraic expressions. So a little background for letter A is, if we have a total of, let's say, a box that contains 72 items, and we want to divide that into 2 parts, how would we go about it? Well, we could say one part is Z. What would the other part be? Well, if the total is 72, it would be 72 minus C. And that's the other number in terms of Z. So 2 numbers have the sum of this. If one number is Z, what's the other number? Well, this is the other number here. The total is 72. Part of it is z. If you subtract z from the total, that's the other number. So this is the algebraic way to express this. Now, during a recent marathon, Tom ran 9 more miles than Judy ran. Now, Judy ran X miles. That's what they're saying. How many miles did Tom run? Well, if Judy ran X and Tom ran 8 more than Judy, Tom would be X, the amount that Judy ran, plus 8. And again, this would be the sum of what Tom ran. On a recent car trip, Raymond drove X miles in one day. On day 2, he drove this many miles more. So on day 1, he drove this. On day 2, he drove that same amount, plus 170 more. How many miles did he drive for both days? Well, we have to add these two together. So it would be 2x plus 170. Again, we'll be spending lots of time on this, and for some of you to have it sink in, you read it more than once, you look at it, you study it, and that's what we move toward in mastery.